Let's learn about adding and subtracting radicals. So there are two rules that you need to know about when we add or subtract radicals. And the first rule is that we want to simplify the radical before we try to add or subtract. So it's possible that after we simplify the radicals that we will get like radicands. Number two, add or subtract like radicands. So you want to think about like radicands the same way you do as when we combine like terms in an equation. So if we have an equation that looks like 3x plus 2y plus 6x plus y, remember that we can only combine like terms if the variable and the exponent are the same. So here I have 3x and 6x. Those both have an exponent of x to the first power. Then I have 2y and y, which both have an exponent of y to the first power. So let's combine like terms by combining the same colors. 3x plus 6x is 9x. 2y plus y is 3y. So when we combine like terms, we have 9x plus 3y. So we're going to do the same process for radicals. So we're going to treat the radical kind of like we would a variable, and then the number outside the radical is going to be treated kind of like a coefficient. So let's look at our examples. The first one is 4 times the square root of 7 plus 2 times the square root of 7. So in this example, we have two radicals, and they have the same radicand. So that means we can combine them by adding the numbers that are outside the radical. So that would give me 6, which is the sum of 4 plus 2, times the square root of 7. So when we add and subtract radicals, we're not changing the radicand whatsoever. We're just adding or subtracting the numbers outside the radicals, or if you want to refer to those as coefficients, you can do that. So my first answer would be 6 times the square root of 7. The next one, number 2, we have 8 times the square root of x minus the square root of x. So we put this one on here because we are subtracting. We have 8x, and on this one we actually have minus 1x. So let's just put that invisible 1 there for the moment. Because I have two like radicands, x and x, I can subtract the coefficient 8 minus 1. And that's going to give me 7 times the square root of x. Number 3, it looks like we have two different types of radicands. We have square root 11, and then we also have square root of 23. So now we know that the numbers in front of those radicals can be combined if the radicands are the same. So here we have 2 times the square root of 11 minus 9 times the square root of 11. So that's going to give me negative square root 11. And then we have positive 8 minus 3, which is going to give me plus 5 times the square root of 23. Number 4, let's go ahead and highlight the like radicands. We have 7 times the square root of 2 plus 6 times the square root of 2. We have negative 11 times the square root of 5 minus the square root of 5. And remember, that really has a coefficient of a minus 1. So let's go ahead and combine like terms. We have 7 plus 6, which is 13 times the square root of 2. Then we have negative 11 minus 1, which would be minus 12 times the square root of 5. So both the square root of 2 and square root of 5 are in simplified terms, so we cannot do anything more than this. Number 5, the square root of 12 plus 6 times the square root of 3. So at first glance, you would say we do not have like radicands, so we can't add or subtract. But we need to make sure that we simplify all the radicals before we make the decision on whether we can add or subtract. So let's go ahead and break this square root of 12 into two factors. square root 4 times the square root of 3. That's going to give me 2 times the square root of 3 plus 6 times the square root of 3. So I'm just bringing this down. Now I have two radicands that are the same, the square root of 3. So that means I'm just going to add the coefficients, 2 plus 6, to get 8 times the square root of 3. Number 6, we have negative 9 times the square root of 5 minus 4 times the square root of 125. So at first glance, we see two radicands that are not the same. But this radicand, this square root of 125, is not in lowest terms. So let's go ahead and see if we can simplify that. So we have negative 4 times the square root of 25 times the square root of 5. Negative 4 times 5 times the square root of 5. So that's going to give me negative 20 times the square root of 5. Well, I'm just going to bring this piece down, negative 9 times the square root of 5. So look what we have here. We have two radicands that are alike. They're both square root 5. So now I'm just going to combine the coefficients, negative 9 and negative 20. That's going to give me negative 29 times the square root of 5. Number 7, we have 2 times the square root of 28 minus 5 times the square root of 63. So at first glance, these two radicands are different, but let's see by simplifying if we can get any like radicands. So let's go ahead with the first one, which is 28. So we're going to carry the 2 down, and then we're going to get the square root of 28 as being square root of 4 times square root of 7. Minus 5 times the square root of 9 times the square root of 7. So all I've done is use the product rule to break out my radicals into two factors. Let's work on this side first, and then we'll work on this side. 2 times the square root of 4 is 2 times 2 times the square root of 7. 2 times 2 is 4, so we get 4 times the square root of 7. Minus 5 times 3 times the square root of 7, so I just simplified the square root of 9. That's going to give me minus 15 times the square root of 7. So now we can see that by simplifying, we do have like radicands. So now we can subtract. So we're going to take our coefficient for minus 15, negative 11 times the square root of 7. Oops. Start over again. Negative 11 times the square root of 7. All right, number 8 is a distributive property. So what we're doing on this is distributing the square root of 2 to both terms that are inside the parentheses. So remember that when we multiply and we have things underneath the parentheses, those are multiplied together. So when we multiply the square root of 2 times 3 times the square root of 6, we're also going to distribute that square root 2 to 5 times the square root of 2. So now we're ready to go ahead and simplify both sides. So we have the square root of 2 times the square root of 6, which would be the square root of 12. And then we have this 3 here. On this one, we have 5 times the square root of 4, which is going to be 5 times 2, which would just simplify to 10. Now remember, for this 12, that's not in simplified form. So we're going to do that we're going to simplify that by breaking it down into two factors, 3 times the square root of 4 times the square root of 3. That gives us 3 times 2 times the square root of 3, or 6 times the square root of 3, plus, we'll bring this down, 10. So my answer would be 6 times the square root of 3 plus 10. So the strategy on any of these with distributive property would be to work on each side separately and then combine them at the end like we did here. Okay, the last one is 3 times the difference of 9 times the square root of 21 minus 8 times the square root of 6. So again, we're going to do the distributive property just like we did in number 8. So we're going to take square root of 3 times 9 times the square root of 21 minus 8 times the square root of 3 times the square root of 6. So all I did was just distribute that square root of 3 to both of those radicals inside the parenthesis. So let's go ahead and simplify. We have the square root of 3 times 9 times the square root of 21. So remember, when we multiply monomials, we multiply the radicands with each other and then the numbers outside the radicals with each other. So on here we do have a 1. So if we multiply 9 times 1, we get 9. And then if we multiply 3 times 21, we get 63. So we have 9 times the square root of 63 minus 8 times the square root of 18. Now, the square root of 18 can be broken down. Okay, so let's go ahead and break that down to the square root of 9 times the square root of 2. And don't forget, we have the minus 8 in front. So on this side of the problem, we're going to get 8 times 3 times the square root of 2. On this side, we're going to break down that square root of 63 into 9 times the square root of 9 times the square root of 7. Now, I'm going to drop down to this other page and finish this. So I'm going to rewrite this. 9 times the square root of 9 times the square root of 7. Oops. Minus 8 times 3 times the square root of 2. Okay. So let's go ahead and do our strategy where we work on one side at a time. So we know that we can simplify the square root 9 to 3. So we're left with 27 times the square root of 7. Minus, on this one we can multiply the 8 and the 3 because they're both constants outside the radical to get minus 24 times the square root of 2. Now on this one we have two different radicands. We have a square root of 7 and then we also have a square root of 2. So this cannot be any further simplified since we don't have like radicands. So our answer would look like this. 27 times the square root of 7 minus 24 times the square root of 2. Thank you for watching. I hope you learned about adding and subtracting radicals today.